In this video, we are going to discuss why when you multiply both sides or divide both sides of an inequality by a positive number, that the inequality signs do not change. Yet when you multiply or divide an inequality on both sides by a negative number, or divide both sides by a negative number, the inequality signs do switch. Let's jump right into it. So 2 is less than 4. We know that because 2 is closer to 0 on the right-hand side of the number line than 4 is, right? 2 is 2 away and 4 is 4 away. So 2 is less than 4, or 4 is greater than 2. Two different ways of looking at the same situation. Now, what I'm going to show you is if I multiply both sides of this equation by any number, let's say that we multiply both sides by 3. So if I multiply both sides by 3, I would get 6 is less than 12. So we would still have that the left-hand side is less than the right-hand side, and that makes sense on a number line. This 2 would move out to a 6, and the 4 would move way out to a 12, so this side is still more than the other side, the 6. So that makes sense that our distance from 0 has just expanded on the right-hand side and on the left-hand side by that same multiple. So now the question becomes, what happens if I multiply both sides or divide both sides by a negative number? Well, if I multiply both sides by a negative number, let's start with the 2 is less than 4, and let's just multiply by a very simple number, -1. We could also divide by -1 as well. It would give us the same result. So if I multiply both sides by -1, I would get -2 and -4. Now -2 is not less than -4, right? -2 is more than -4, right? And the reason being is actually pretty simple and very cool. -2 is the same distance from 0 that 2 is, just like -4 is the same distance from 0 that 4 is. However, when we're comparing the two sides here, being closer to 0 on the negative side means you're now greater than the other number that is farther from 0. And that is why when you multiply by a negative number, you are going to end up needing to switch the inequality signs. So it's more than just a rule that you say, multiply or divide by negative, must switch the signs. It's more than that. It's about how close you are to 0. It's pretty neat. Now we could look at this with division as well. So let's say that I take 2 and 4 and I divide by -2. So 2 divided by -2 is -1. 4 divided by -2 is -2. And so we still see that the inequality signs need to switch. The reason being is, since you divided by the same amount, both these numbers are being divided by the same amount. They're both being reduced by that same number. And so the 2, the left-hand side, which was closer to 0 to start, is still closer to 0 after you divide by -2. And closer to 0 on the negative side means that you are greater than what is farther from 0. Isn't that cool? I think it's pretty rad. So I've written out another little example here, just with the number line, just to show you that it doesn't really matter if we multiply or divide by negative numbers. So we can also, let's see, multiply by a negative number other than -1. So let's say that I multiply by, I don't know, -10, right? If I multiply by -10 here on both sides, it's a big number. Well, when I do that, this becomes -20, and the inequality will come back to, this is -40, and so -20 is greater than -40. So I'll put the zeros in here. I got lazy and didn't put in zeros. So basically what we're saying is we started with 2 is less than 4, and then we end up with -20 and -40. For the same reasoning, we have that -20 is closer to 0 than -40 is. And again, closer to 0 on the negative side means you're greater. So yet another example of why when you multiply or divide by negative numbers, the inequality sign must switch. So I hope that that was helpful for you. I think it's more than just a rule. You need to understand the closeness to 0 and why it is that we switch signs when we multiply or divide by negative, and then the rule will stick and be a lot less than just straight memorization.